Hello, everybody. Let me introduce myself. My name is Andrei Rosa. I work in the Presto team, and my main area of focus is scaling Presto to support larger workloads. And today, with my colleague, we are going to talk about running Presto on Spark.
Ariel, you have a question?
Today we are going to discuss general motivation for this effort. Also, we'll have a quick overview around Presto Spark design. We also got some early results. Then we'll have a quick update on the current development status of this project. And at the end of this presentation, we will have a Q&A session. So first, I would like to start with a quick Presto architecture overview, the current Presto architecture. So originally, it was designed to serve interactive use cases. It has many characteristics of a classic MPP database, such as in-memory stream and shuffle. With in-memory stream and shuffle, it is possible to run more operations in parallel that results in lower latencies. It is also, Presto is deployed as a standalone multi-tenant managed service. It is always warm, so there is no startup delay when you issue a query. This model of deployment also allows us to better share the resources. Like, for example, if cluster is idle, we can increase parallelism for a single or for the running queries. It also allows more efficient memory sharing. But of course, it has some trade-offs. So it has its own scalability limitations. So in our current deployment at Facebook, our distributed memory limit per query is set to 5 terabytes. And because of the streaming nature of Shuffle, the aggregations and joins have to be processed all at once. So it limits the maximum size of join and aggregation effectively to 5 terabytes. The other limitation of this architecture is that the number of workers in cluster is limited to around 600. And because of the end-to-end shuffle, the number of reducers is even lower. Currently, in our deployments, it is around 300 reducers. The number of reducers is lower because with a streaming shuffle, we need to do end-to-end exchange that doesn't really scale well. And the number of workers is limited by the fact that we are using a single coordinator that is shared by all the queries that are currently running in a cluster. We're actually trying to remove this limitation. There is a project of trying to scale our coordinators to be able to run multiple coordinators per cluster, but so far it is still a single coordinator per cluster. For our workloads, we did some analysis and we found out that a query that runs for more than 8 hours has only 50% chance of succeeding. It is mainly because the fact that Presto doesn't offer any failure recovery. Also, all the queries are run in multi-tenant environments, so there's always a chance of like a bad query kicking in. And because of no resource isolation, that bad query can also negatively impact all the other queries that are currently running in a cluster. So as you may already know, at Facebook, we run Presto for batch. We not only use Presto for interactive workloads, but also for large ETL processing. That's why overcoming all these limitations is so important, because usually large batch ETL queries require higher memory limits, higher parallelism, and higher reliability due to their long-running nature. Before Presto on Spark, Wenlei and I were working on this project called Presto Unlimited. So the idea of Presto Unlimited was to bring MapReduce style execution to MPP database architecture. So the idea is to, instead of using end-to-end streaming shuffle, to store intermediate data on disk. And since we store intermediate data on disk, it allows us to more granularly process joins and aggregations. So instead of trying to load all data in memory, we can load only some number of shards at a time and process them. So that gives us ability to run large memory queries that would require more than 5 terabytes of memory. It also increases reliability by allowing partial file recovery. Since the intermediate data is on disk, we can restart a single reducer, or in some cases, we will also need to restart. We can restart a whole stage, or as we call it, section. And what is really amazing about Presto Unlimited that it doesn't require anything, any additional deployments. It can be run on existing Presto clusters along with all the other queries that are running in the streaming mode. But unfortunately, Presto Unlimited has its own limitations. So the first limitation that is very important for us is basically that the number of workers still limited to the number of nodes in the cluster. That is, in our case, around 600 nodes. There is still no resource isolation. All the queries they share the same JVM, the same cluster. So it is possible that one bad query can still negatively impact reliability of all the other queries that are currently running in the cluster. In some cases, Presto Unlimited is still lacking of granular failure recovery. As I already said, in some cases, we cannot restart a single mapper or reducer. We have to still restart the entire stage. That also can be improved. And the last most important limitation that we are lacking in Presto Unlimited is basically with current Presto deployment model. It is very hard to be flexible at utilizing off-peak capacities. In other words, it is hard to add and remove workers from an existing Presto cluster. So with all these limitations, we started to look at how Spark is trying to solve this. And with Spark was originally designed for this large-scale, reliable ETL processing. So it was built from ground up to support very granular failure recovery. It also runs queries in isolated containers for each query. So each query has its own, runs on its own JVMs. Also, Spark's model of execution supports thousands of mappers and reducers that can be run in parallel. It is due to the fact that Spark provisions a separate driver or kind of current coordinator in terms of Presto for each query. Also, the shuffle algorithm in Spark is more scalable. And in addition to that, Spark also supports plugging in a disaggregated shuffle service, such as Apache Trail, or at Facebook, we have our own shuffle service that is called Costco. Spark is also much more flexible at resource allocation. So since it was designed for very granular failure recovery, it is very easy to add remove workers by simply killing a worker and returning it back if it was requested by some other job. So of course the question is, why not to simply use Spark? So this is a very good question, and the answer, there's actually a couple of reasons to why do we want to run Presto evaluation engine in Spark instead of like simply translating our queries to Spark. So first of all, we want to reuse Presto SQL. We don't want to translate. As translation-based solutions, they usually don't scale, as we are always hitting this long tail of not compatible queries or queries with slightly different semantics. So the translation solutions, unfortunately, it's not scalable. The other reason is are the UDFs. Presto has a set of unique UDFs that would require to be translated to Spark if we wanted to run and translate Presto queries to Spark. Additionally, Presto SQL has some features that Spark SQL doesn't support, like for example, lambdas. Lambda functions are used to to do some various operations on complex types. Also, Presto, for example, it has very powerful geospatial toolkit. And in addition to that, Presto is a very powerful engine for query federation. So Presto allows not to only query HDFS or Hive, it allows to join different query sources, like for example, MySQL or Cassandra or many other different sources. And Presto also has a very efficient columnar evaluation engine that recently become even more efficient with project area. And columnar evaluation is can be very beneficial for many different workloads. Okay, so let's quickly discuss the Presto and Spark architecture. So with Presto and Spark, we are trying to run a Presto evaluation engine as a library within Spark execution. So it has no dependency on existing Presto deployment model. So to run Presto and Spark, you don't actually need a Presto cluster. Only what you need is the Presto and Spark packages and existing Spark cluster. And you can think of it as a custom batch job. So what it does on Spark driver, we run Presto code to parse Presto query, to plan it, and create a Presto distributed plan that then further getting translated into a Spark RDD. This is a data graph in Spark. So then the Spark RDD is run on Spark cluster, and Presto evaluation code is executed as some opaque mappers and reducers in Spark. We have a detailed design doc, so you can, if you're interested, you can have a look and get more information. So here's an example of a Spark RDD generated by a Presto query. So as we can see, this is a simple query that has a join and aggregation on top of it, and does some order by addend. So as you can see, there are two stages that do scanning, stage 0 and stage 1. Then stage 2 does partition by to shuffle data by the join key, and does zip partition to perform join. And then it does another level, a round of shuffle, to perform aggregation on order date. And at the end of the day, it does another shuffle to sort the output and produce the results. So as I said, to run Presto on Spark, we need no existing Spark cluster. So everything can be run by simple Spark submit command that takes Presto on Spark packages as arguments. So other arguments are basically the config, the catalogs configuration, and of course the SQL query file. So we run some tests on our in our internal Spark. So far we've been able to run a query that would otherwise require more than 50 terabytes distributed memory in Presto. So it was like a 10x. We increased the distributed memory limit by a factor of 10x. We also managed to reduce by the factor of 3x the execution time of some queries by allocating more resources to process a query. So it was 4,000 workers in Spark versus 600 workers in Presto. But unfortunately, we've seen some increase in CPU time when running Presto on Spark. We haven't done detailed analysis yet, but we suspect that it might be related to the fact that Spark currently requires, Spark currently does sorting of intermediate data that is actually not needed by Presto because Presto always does hash join. And our format for intermediate shuffle is not very efficient. We basically implemented some very basic prototype. So there is still some room for improvement.
So this number is very preliminary, and it's also very like the workload dependent. So it's possible that we fix one config or one line of code, it suddenly becomes like 20 or 30% better in terms of performance. So please don't count on the data, the 35 to 50 time increase in CPU time. Also, I would like to mention is in general, like trying to use so the MapReduce architect kind of increase the CPU time, but it also it kind of disaggregate the computation from the shuffle, so you can provide this so-called serverless computation, which means you can better use offline, off-heap, sorry, not off-heap, but off-peak computation resources. So thinking about if you have some spare capacity, you can get more mappers, and they can be killed or paused, or they can be finished in a few minutes. While it's impossible in the in-memory shuffle because the shuffle has to be done in all or nothing fashion. Basically, you cannot pause the shuffle in the traditional Presto or MPP world. While in the MapReduce world, like you have much fine granularity computation unit.
And a couple of words of the current development status. So the initial version is already merged to open source. It doesn't support all query shapes yet. We're still working on supporting more. So it doesn't support the n-way join yet. It is only two-way join for now. It doesn't support broadcast join. So, and broadcast join is often required by cross join and non-equi joins. So it's not supported yet. We're working on adding support for that. It also doesn't have an integration with bucketed tables. So it doesn't recognize bucketed tables, and it would process bucketed tables as if they were not bucketed. So we're also working on removing this limitation. Of course, we're working on improving CPU efficiency. And we're also working on better integration with Spark, as Presto and Spark threading models are a little different. So we're still trying to figure out what is going to be the best model of integration. So those are the major working items that we are in the middle of. That's pretty much it from us. And we can have a little Q&A session if we still got some free time.
There are some questions already. So Kishore's question is about when, let's see, what's the recommendation for using process ingestion ETL for processing high volume of data processing, and about Spark versus Presto. So I think in our experience, Presto on Presto, so let's call it Presto on Presto and Presto on Spark and Spark on Spark. Presto on Presto seems to work well when you have like a few hundred workers and a few PB data. Then you can still work well, you know, if you try to increase one magnitude large, but also you also kind of expect the operation overhead and the fine tuning is going to be much more larger. So I think at Facebook, our Presto batch handles that like the EB scale warehouse, but of course and with yeah, but and I think but also the operation overhead is quite large. Yeah. I think I can say the number of Presto workers is also at least one magnitude larger than a few hundred workers. But yeah. But to handle at this level, we feel like we need a Spark style handling. So Yu Chen has the question, what do you mean using Presto as a library on top of Spark? So the plan is generated by Presto, and the evaluation code is also generated by Presto. So thinking about you are launching a custom batch job on Spark, and that custom batch job is basically we are generating those RDD graphs, but inside the RDD, the actual evaluation logic is done by calling the Presto library. Wei Han has this question about what's the percentage breakdown of batch jobs running on Presto versus Spark. So, don't know, do you want to answer this, or like how much how accurate data I can share there? So at a high level, both of them takes non-trivial portion. Let's say, I would say Spark takes the majority of the CPU, but Presto also takes the non-trivial part of the CPU. By non-trivial, I mean like two digits. So speaking of the Prestos, from the call site, from the number of queries perspective or number of pipeline perspective, actually Presto has a much larger portion of the ETL jobs, because even in the ETL world, our observation is like the majority of the pipelines like finished in 1 hour, which is kind of the sweet spot for Presto. Alexa has a question. What are the main technical and non-technical challenges with Presto on Spark that you expect? So, okay, I will start with the non-technical challenge. So essentially, it's kind of a job that kind of needs. So when user write Presto on Spark jobs, it kind of needs to be aware by both Presto and the Spark team, because the runtime is on Spark and the evaluation library is on Presto. So I would expect from operation perspective or user support perspective, how to routing users' problems accurately to Spark or Presto team, instead of first the user asks Presto team and the Presto team says, no, this today it's a problem for Spark runtime, or like, yeah. The technical challenge, I think Andrew kind of summarized it in his last slide, including, what's the threading model, like how do we support broadcast join, and essentially it's about how do we run the MPP style database on a more general data flow execution engine, and it's kind of a, yeah. So Oh, Nan has this question about the row-oriented format in Spark. So in general, Presto, when Presto does the shuffle, it's still doing column shuffle. So if you look at the shuffle code in Presto, it's shuffling the Presto page format. So what we found is this scales well for hundreds of reducers or exchange things. But when you have thousands or even tens of thousands, so because the problem is you have to maintain a buffer for every destination, right? So when you have thousands or even tens of thousands reducers, to keep the buffer size not too large, you kind of say each destination has to be much smaller, which often end up with like you have a page. That page only have like a few rows or a few positions or 10 positions. Then you have to flush it out. And in Presto, the overhead for a page is not trivial. So instead of doing the traditional column-oriented shuffling, we kind of say, hey, every time we flush one row at a time in Presto Spark. And I think
this is Amit here. We want to basically be mindful of the speaker's time as well. So maybe we can take these. We'll have a copy of these questions available, and I think we can just follow up with the attendees. This was really a good discussion. Thank you all for having this conversation. But